करो फटाफट। बहुत स्ट्रेट फॉरवर्ड है, डायरेक्टली फॉर्मूला अप्लाई करेंगे। DCO is equal to RC plus RO minus 0.09 electronegativity of oxygen minus electronegativity of carbon, 0.75 plus 0.7 minus 0.09 into difference is 1 point, आ जाएगा 1.45 minus 0.09 is equal to 1.36. So we are doing applications of electronegativity. थर्ड पॉइंट किया हमने predicting bond length। ऐसे देखो, अगर दो एटम्स हैं और इलेक्ट्रोनेगेटिविटी डिफरेंट है तो एक एटम पे डेल्टा प्लस आएगा, एक एटम पे डेल्टा माइनस आएगा। ठीक है, अगर डेल्टा प्लस डेल्टा माइनस आएगा एटम्स पे तो एटम्स के बीच का अट्रैक्शन इंक्रीज हो जाएगा। There will be a stronger attraction between the atoms. It will result in a shorter bond length. So we can say that the bond length decreases due to the electronegativity difference between the bonded atoms. More is the electronegativity difference, shorter is the bond length. ठीक है, उसका ही फॉर्मूला किया हमने और एक स्ट्रेट फॉरवर्ड एक सिंपल सा क्वेश्चन किया उस पे बेस्ड हम। अंडरस्टूड आर्यन? एप्लीकेशंस ऑफ इलेक्ट्रोनेगेटिविटी में फोर्थ पॉइंट देखो, प्रेडिक्टिंग एसिडिक और पहले प्रेडिक्टिंग मेटालिक और नॉन मेटालिक नेचर। डिफरेंट एलिमेंट्स में मेटालिक और नॉन मेटालिक नेचर प्रेडिक्ट करना है। ठीक है, so in general we say that more electronegativity, more is the non-metallic character, less electronegativity, more is the metallic character. So we can say that metallic nature is inversely related to electronegativity. And non-metallic nature is directly related to electronegativity. तो ज्यादा इलेक्ट्रोनेगेटिविटी मतलब ज्यादा नॉन मेटालिक, कम इलेक्ट्रोनेगेटिविटी मतलब ज्यादा मेटालिक। ठीक है, एंड वाइस वर्सा। Based on this, we talk about acidic or basic nature of oxides, predicting acidic or basic nature of oxides and hydroxides. Normally, oxides plus water give hydroxides. Okay, oxides have element oxygen bond, where E is an element. Hydroxides have EOH bond. जैसे एग्जांपल देखो, Na2O plus water gives NaOH. Talking about acidic oxides such as N2O3, N2O3 plus H2O giving HNO2. Okay. Even in HNO2, we have an nitrogen oxygen hydrogen bond as a structure. So we know that this is a base and this is an acid. Even base as well as an acid both contain element oxygen hydrogen bonds. So all oxides, when dissolved in water, will result in formation of a compound which has a hydroxide group. जैसे यहाँ पे भी देखो, इस एसिड में भी एक नाइट्रोजन ऑक्सीजन हाइड्रोजन बॉन्ड है, और बेस में तो हाइड्रोक्साइड ग्रुप है ही. एसिड आल्सो हैज हाइड्रोक्सिल ग्रुप्स. Even both acids as well as bases have hydroxyl groups. Okay. Oxides, when dissolved in water, produce a compound which have hydroxide groups in there. Itna clear hai? Now we know that some oxides are acidic in nature, some oxides are basic in nature, some oxides are amphoteric in nature. Okay. What are acidic oxides? What are basic oxides? What are amphoteric oxides? Acidic oxides are those oxides which can be dissolved in bases. Basic oxides are those oxides which can be dissolved in acids. And amphoteric oxides are those oxides which can be dissolved in both acids as well as bases. So we know mainly three types of oxides. एक बार फटाफट ये definition लिख लेते हैं. Then we'll understand how to predict the acidic or basic nature on the, from electronegativity of an element. ठीक है, ये नोट कर लो. जनरली ऑक्साइड्स को डिसॉल्व करके जो एसिड्स बनते हैं ना, उन एसिड्स को हम ऑक्सी एसिड्स बोलते हैं, एंड दे कंटेन हाइड्रोक्सिल ग्रुप्स. अंडरस्टूड वीरो? Yes, yes, we'll finish today. पेज टर्न करूं? Oxides can be classified into four categories. इसमें पहला है acidic oxides. They dissolve in water to give acids. Hence, they are also known as they're also called acid anhydrides. They react with bases to form salt and water. And generally, non-metal oxides are acidic oxides. Examples of some acidic oxides are CO2, NO2, N2O3, N2O5, SO3, SO2, etc. These oxides dissolve in water to give an acid. N2O3 plus 2H2O gives 2HNO2. Okay. SO3 plus H2O gives H2SO4. These oxides dissolve in bases to form salt and water. Example, N2O5 plus 2NaOH giving 2NaNO3 plus H2O. So they react with bases to form salt and water. We can note these points. And this is an acidic oxide. This is a base. They react with base to give salt and water. Okay. 1 second रुकना. Then we have basic oxides. Basic oxides, they dissolve in water to give bases. They dissolve in water to give alkalis. They react with acids to give salt in water. Generally, metal oxides are basic in nature. Let's say non-metal oxides are acidic. Similarly, generally, metal oxides are basic. Examples of some basic oxides: Na2O, K2O, CaO, FeO, etc. They dissolve in water to give bases or alkalis. CO plus water gives COH twice. Na2O plus water gives 2NaOH. They dissolve in water to give bases. They react with acids to form salt in water. Na2O plus HCl giving 2NaCl plus H2O. The basic oxide react with acids to give salt and water. ठीक है, क्लियर है ये बेसिक ऑक्साइड्स का डेफिनेशन. Then we have amphoteric oxides. Amphoteric oxides show similarities to both basic as well as acidic oxides. They react with both acids and bases to form salt and water. Both acids and bases to form salt and water. Amphoteric oxides react with acids as well as bases. They tend to behave as acidic oxide also. They tend to behave as basic oxides also. Some metal oxides are amphoteric. We need to memorize that list. Some metal oxides are amphoteric. Which are the metals which form amphoteric oxides? ये list मैं next page में लिखाता हूँ. ये जल्दी से नोट कर लो. Lead, aluminium, zinc. These are some of the metals which form amphoteric oxide. There are some other metals also. ये list मैं next page में लिखाता हूँ. Next, list of amphoteric oxides. Oxides of zinc, beryllium, aluminium, chromium, ऐसे लिखना है जिंक, aluminium, beryllium, chromium, lead, tin, arsenic, antimony, gallium, etc. are amphoteric. The oxides of zinc, beryllium, aluminium, chromium, lead, tin, arsenic, antimony, gallium are amphoteric. These oxides will dissolve in bore acids as well as bases. Let us take an example. Zinc oxide is an amphoteric oxide. It reacts with acids as well as base to form salt and water. Acid के साथ NaCl2 plus H2O salt and water बन गया. It also dissolves in bases to give salt and water. The amphoteric oxides react with acid as well as bases. Not necessarily metalloids. Because zinc, aluminium, beryllium are not metalloids, they are metals. So generally, some metal oxides are amphoteric. Even oxides of metalloids can be amphoteric. Arsenic, antimony, gallium are closer to being metalloids than being metals. Now, most of them are not metalloids. Zinc, aluminium, beryllium, chromium, tin, lead, ये सब थोड़ी metalloids है. विरोध. ठीक है? We have something called as neutral oxides also. Fourth type of oxide, neutral oxides. What are neutral oxides? They react neither with acids nor with bases. इस डेफिनेशन में H2O फिट नहीं होगा क्योंकि हम एसिडिक ऑक्साइड और बेसिक ऑक्साइड को वाटर के रिस्पेक्ट में डिफाइन करते हैं. ठीक है? फिर भी मोर अप्रोप्रिएट डेफिनेशन फॉर वाटर कैन बी water is a amphoteric oxide because water reacts with acids as well as bases. Water acid से भी react करता है, water acidic oxide से भी react करता है, water basic oxide से भी react करता है. The more appropriate term for water will be an amphoteric oxide. The neutral oxides they react neither with acid nor with bases. There are very few examples of neutral oxides. एक example है CO, एक example है N2O और एक example है NO. These are examples of some neutral oxides. अभी के लिए हमें बस इतने ही एग्जांपल्स याद रखने हैं. CO, N2O and NO, which react neither with acids nor with bases. बोलिए आर्यमान, क्या बोल रहे हैं? How to determine whether an oxide or hydroxide formed by an element will be acidic or basic or neutral. It is related to electronegativities. Let us consider the element oxygen hydrogen bond in a hydroxide. ठीक है, दो अलग अलग एग्जांपल्स लेते हैं. अच्छा, व्हाट इज द इलेक्ट्रोनेगेटिविटी ऑफ ऑक्सीजन? ऑक्सीजन की इलेक्ट्रोनेगेटिविटी है 3.5 and that of hydrogen is 2.1. ठीक है. सपोज एलिमेंट सोडियम है एंड सपोज एलिमेंट इज नाइट्रोजन. दो अलग अलग एलिमेंट, एक मेटल एक नॉन मेटल के लिए एग्जांपल्स लेके करते हैं. इफ एलिमेंट इज सोडियम and if element is nitrogen, इलेक्ट्रोनेगेटिविटीज देखेंगे. सोडियम की इलेक्ट्रोनेगेटिविटी है 0.9, नाइट्रोजन इज 3. यहाँ पे डेल्टा एक्स फॉर द एलिमेंट ऑक्सीजन बॉन्ड इज 2.6. यहाँ पे डेल्टा एक्स फॉर द एलिमेंट ऑक्सीजन बॉन्ड इज 0.5. यहाँ पे हम देखेंगे विच बॉन्ड इज मोर पोलर. डेल्टा एक्स फॉर ऑक्सीजन हाइड्रोजन बॉन्ड इज 1.4. ठीक है. अभी EOH in this entire molecule, EOH, element oxygen hydrogen, there are two bonds. One bond is element oxygen bond, another bond is oxygen hydrogen bond. In the two bonds, the more polar bond will be the one where electronegativity difference is more. In the first case, for sodium, it is found that the delta X for EO is greater than delta X for OH. Therefore, EO bond is more polar. More polar and ionizes in solution. जो बॉन्ड ज्यादा पोलर होगा वो सॉल्यूशन में आयोनाइज हो जाएगा. So when this dissociates, it will form Na plus and OH minus. The element oxygen bond ionizes. OH minus ions results in a basic solution. Whereas in this case, for the nitrogen atom, delta X for element oxygen is only 0.5. Delta X of EO bond is less than delta X of OH bond. यहाँ पे हम बोलेंगे OH bond is more polar and ionizes in solution. जो बॉन्ड ज्यादा पोलर होता है वो बॉन्ड ज्यादा आसानी से आयनाइज होता है. तो यहाँ पे अगर आयनाइजेशन देखेंगे तो NO remains bonded, O पे माइनस और H पे प्लस. यहाँ पे सॉल्यूशन में H प्लस आयंस बनेगा, सॉल्यूशन becomes acidic. ठीक है. All depends on electronegativity of the element E. If the electronegativity of element E is high, that means the delta X of EO bond will be low. It results in acidic nature. If electronegativity of E is low, then delta X for EO bond will be high, resulting in basic nature. We'll say that elements of lower electronegativities result in basic hydroxides or oxides. Element with higher electronegativities result in acidic oxides or hydroxides. ठीक है, आ रहा है समझ में ये पॉइंट? नोट कर लो जल्दी से. We have this point. For oxides or hydroxides or oxyacids, Acidic nature is proportional to electronegativity. More is the electronegativity, more is the acidic nature. Basic nature is inversely proportional to electronegativity. इसमें example देखो, compare the acidic nature of SO3Cl2O7, which is more acidic. The chlorine is more electronegative than sulfur. This is the order of acidic nature. Cl2O7 is a stronger acidic oxide than SO3. Or we can compare their corresponding acidic strengths also. H2SO4 is a weaker acid than HClO4. Both are strong acids, but relatively HClO4 is a stronger acid than H2SO4. Talking about basic nature, Na2O is more basic than MgO. Less electronegative atoms will result in more basic character. HClO4 is known as perchloric acid. It's a stronger acid than sulfuric acid. Now we will discuss in brief two more factors of electronegativity. इसमें एक factor है hybridization. We'll talk about this hybridization in chemical bonding. हम लोग लिख सकते हैं electronegativity is proportional to percentage S character of hybrid orbitals. अभी बस नोट कर लो ये पॉइंट, एक्सप्लेन बाद में करूंगा मैं ये. There are mainly three types of hybridization which we come across in the second period elements: sp, sp2 and sp3. What is this? इसका exact meaning बाद में करेंगे, but brief में समझ लो. Hybridization is intermixing of orbitals. ठीक है, तो s and p orbitals, they intermix to form some new orbitals which are called as hybrid orbitals. और इन hybrid orbitals में s character ज्यादा होगा तो electronegativity ज्यादा होगी. More s character मतलब more penetration towards the nucleus. More penetration towards the nucleus means stronger attraction by the nucleus, so more electronegativity. sp hybridization, sp2 and sp3 are accordingly defined. sp is made up of one s and one p orbitals. It has 50% s character. sp2 has 33.33% s character, and sp3 has 25% s character. So more s character, more electronegativity. ठीक है. So what is sp, what is sp2, what is sp3? Detailed explanation will be given in chemical bonding. But there are types of hybridization, different types of hybridization. sp hybridization में 1s hybridizes with or intermixes with 1p orbital. ठीक है. And sp2 में s का एक ऑर्बिटल p के दो ऑर्बिटल्स इंटरमिक्स है. sp3 में s का एक ऑर्बिटल p के तीन ऑर्बिटल्स इंटरमिक्स है. आ रहा है समझ में ये पॉइंट? नेक्स्ट देखो, there is one more factor, that is the oxidation number. Okay, detailed definition we'll discuss later. Oxidation number, it is the charge on an atom. It effectively refers to the charge on an atom. If the bonds were ionic instead of covalent. जैसे, और हम बोलते हैं इलेक्ट्रोनेगेटिविटी इज प्रोपोर्शनल टू ऑक्सीडेशन नंबर. एग्जांपल अगर देखेंगे, FeO and Fe2O3, charge on iron is +2 in the first compound, +3 in the second compound. Okay, so as oxidation number of iron increases, electronegativity of iron increases. So we'll say that electronegativity of Fe in Fe2O3 is more than that in FeO. More electronegativity means less basic nature. तो basic nature कंपेयर करेंगे amongst FeO and Fe2O3, it will be FeO greater than Fe2O3. ठीक है, more electronegativity, less basic, less electronegativity, more basic. तो FeO में आयरन पे कम चार्ज है, lower charge, lower oxidation number results in lower electronegativity. तो जिसमें इलेक्ट्रोनेगेटिविटी कम है उसका बेसिक स्ट्रेंथ ज्यादा आएगा. बेसिक स्ट्रेंथ इज इनवर्सली प्रोपोर्शनल टू इलेक्ट्रोनेगेटिविटी. आ रहा है समझ में? जैसे एक और एग्जांपल देख लो, MnO, Mn2O3, MnO2, MnO3, Mn2O7. यहाँ पे सब में ऑक्सीडेशन नंबर्स बढ़ रहे हैं, +2, +3, +4, +6, +7. We'll say that as oxidation number of manganese increases, its electronegativity increases, acidic strength of these oxides increase. ठीक है, यहाँ पे ध्यान से देखना. We know experimentally that MnO is a basic oxide. Mn2O3 is an amphoteric oxide. MnO2 is a neutral oxide, whereas MnO3 and Mn2O7 are acidic oxides. ठीक है, तो मैंगनीज के लिए ये सारी डिफरेंट ऑक्सीडेशन स्टेट्स पॉसिबल है. All these 4 different types of oxides are possible for manganese. फटाफट नोट करो ये. The last topic which we'll be doing is hydration energy. Definition wise, it is the hydration energy or hydration enthalpy. It is the energy released when 1 mole of gaseous ions gets surrounded by water molecules. एक सेकंड रुकना, फिर से लिख रहा हूं मैं. It is the energy released when 1 mole of gaseous ions gets surrounded by water molecules in aqueous solution. चलिए डेफिनेशन लिखो, मैं नेक्स्ट पेज में एक्सप्लेन करता हूँ. It is the energy released when 1 mole of gaseous ions gets surrounded by water molecules in an aqueous solution. रन करूं? नेक्स्ट देखो, when ionic compounds are dissolved in water, the ions formed get surrounded by water molecules. So when a plus, the sodium ion gets surrounded by water molecule, the chloride ion gets surrounded by water molecule. So ये Na plus ions है. वाटर मॉलिक्यूल में ध्यान से देखेंगे तो वाटर मॉलिक्यूल में हाइड्रोजन एंड हैज डेल्टा प्लस चार्ज and oxygen end has delta minus charge. The delta minus of oxygen will be attracted towards the cation. This attraction results in surrounding of cations on all sides by the water molecule. Okay. This process where cations or anions get surrounded by a large number of water molecules is called as hydration. The process in which ions or bracket molecule or any other solute gets surrounded by a large number of water molecules is called hydration. The energy released during this process is called hydration energy. ठीक है? अगर वाटर की जगह कोई और सॉल्वेंट है तो इसको हम सॉल्वेशन भी बोलते हैं. Hydration is equivalent to solvation. Hydration term use करते हैं हम for water as solvent. Solvation term हम use कर सकते हैं for other solvents. Also for water. ठीक है? Similarly, जैसे hydration energy is defined for only water as a solvent. For any solvent. जरूरी नहीं है other solvent, for any solvent. Hydration energy is a term used only for water. Solvation energy is a term that can be used for any solvent. आ रहा है समझ में ये point? So solvation is a general term. Or if the solvent is water, then solvation is called hydration. The solvation energy is a general term. If the solvent is water, solvation energy is called hydration energy. The energy released during the process of solvation is called solvation energy. Okay? For water as a solvent, the process of solvation is called hydration and the energy released is called hydration energy. आ रहा है समझ में? By definition, it is defined with respect to an isolated gaseous atom. If we have Na plus gaseous, isolated gaseous sodium atoms on addition to water, they will give Na plus aqueous. During this process, some energy is released. That energy release is called hydration energy or hydration enthalpy. Value of hydration enthalpy will be negative because the process is exothermic. Suppose we have gaseous chloride ions. On addition of water, we'll get aqueous chloride ions, in which chloride ions will get surrounded by water. In this process, some energy will be released, which is called the hydration energy of chloride ions. Hydration energy has a negative value. Delta H hydration energy has a negative value. Okay? Because it is an exothermic process. ठीक है? आ रहा है समझ में ये point? नेक्स्ट देखो, factors affecting hydration energy. Hydration energy is proportional to charge. More is the charge on the ions, more will be the hydration energy. If you compare between Na plus Mg2 plus Al3 plus, as the magnitude of charge increases, hydration energy increases. ठीक है. Hydration energy is inversely proportional to size. Smaller ions will result in stronger attraction, more hydration energy. Okay. And larger ions will result in less attraction. Actually, it depends on charge density, and charge density will depend on charge by size. Smaller ions result in greater charge density, resulting in stronger attraction for water molecules. Thus, higher hydration energy. Therefore, hydration energy is inversely proportional to size. इसमें compare करेंगे order of hydration energy. Li plus has a greater hydration energy than Na plus, then K plus, then Rb plus, then Cs plus. Larger is the size, as size increases, hydration energy decreases. आ रहा है समझ में ये point? The two factors that affect hydration energy, it is directly proportional to the magnitude of charge on the ion. More is the charge, more is the hydration energy, and it is inversely proportional to the size of the ions. Smaller size results in higher hydration energy. Now we'll do some applications of hydration energy. तो फटाफट नोट कर लो. इसके बाद we'll do ट्रेंड बहुत सिंपल होगा. ट्रेंड्स लिख देते हैं. प्रैक्टिस हम ट्रेंड्स लिख सकते हैं. ट्रेंड्स इन हाइड्रेशन एनर्जी. इसके बाद एप्लीकेशंस लिखेंगे. In general, in cations, it increases from left to right. बट चूंकि ऐसे कंपेयर नहीं करते, एक कैटायन को एक एनायन को कंपेयर नहीं करते, तो केवल कैटायन के लिए कंपेयर कर सकते हैं, केवल एनायन के लिए कंपेयर कर सकते हैं, ठीक है। एंड टॉप टू बॉटम इट विल डेफिनेटली डिक्रीज। जैसे हमने कैटायन और एक एग्जांपल किया ही, Na प्लस Mg2 प्लस Al3 प्लस, ठीक है। एनायंस में उल्टा हो जाएगा, ठीक है। एनायंस में अगर देखेंगे more charge, more hydration energy. N3 minus will have more hydration energy than O2 minus, than F minus. Decreases from left to right. ठीक है। In cations it increases from left to right. In anions it decreases from left to right. Understood? And it decreases from top to bottom in a group. As size will increase, it will decrease from top to bottom in a group for both cations and anions. So these are the two important trends. Applications of hydration energy. Comparing the size of hydrated ions. यहाँ पे हम लिखेंगे size of hydrated ion is proportional to the extent of hydration. Which in turn is proportional to hydration energy. बहुत ही important example है, simple सा example है. If you compare the size of Li plus, Na plus, K plus, Rb plus, if you compare the size of the gaseous ions from top to bottom, size increases. But if you compare the size of their aqueous ions, Li plus aqueous is found to be larger than Na plus aqueous, is found to be larger than K plus aqueous, is found to be larger than Rb plus aqueous. The cause is, the smaller the gaseous ion, more will be the extent of hydration. More is the extent of hydration, it results in larger net size. कैसे समझो, लिथियम से सोडियम थोड़ा बहुत साइज बढ़ेगा, सोडियम से पोटेशियम थोड़ा बहुत साइज बढ़ेगा, पोटेशियम से रुबिडियम साइज बढ़ेगा, ठीक है। These are the size of the gaseous ions, but if we consider their hydration also, ठीक है, considering hydration, a large number of water molecules will hydrate the lithium ion, but relatively a smaller number of water molecules will hydrate this rubidium or the cesium ions. As a result, ये जो larger size बनाया मैंने, along with lithium, we have some water molecules. So this larger one is hydrated lithium ion. This is hydrated rubidium ion. तो जो आयन एक्चुअली छोटा है, जो पहले से छोटा है, जैसे लिथियम इज स्मॉलेस्ट, Li plus gases is the smallest of all the alkali metals, but smaller size will result in stronger attraction for water molecules. Stronger attraction for water molecules will result in greater hydrated radius. So hydrated radius of lithium is maximum. ठीक है, 1 मिनट. समझा ये पॉइंट? काफी इंपॉर्टेंट पॉइंट है. तो स्मॉलर इज द एक्चुअल आयन, मोर इज द हाइड्रेशन, मोर इज द एक्सटेंट ऑफ हाइड्रेशन. तो हाइड्रेटेड आयन का साइज बढ़ जाएगा. Hydrated lithium ion is actually larger than hydrated sodium ion, is larger than hydrated potassium ion, is larger than hydrated rubidium ion. ठीक है, क्लियर है ये पॉइंट? पेज टर्न करूं? दो और एप्लीकेशन से ये फिनिश कर लेते हैं, फिर तुम लोग बुकलेट सॉल्व करना. Comparing ionic mobility in aqueous solutions. Mobility is a measure of ease of movement. Generally, larger ions have lesser mobility, smaller ions have more mobility. So we'll say that ionic mobility in solution is inversely proportional to hydrated size of hydrated ion. Which in turn is inversely related to the hydration energy. More hydration energy, more is the hydrated ion size, less is the ionic mobility. तो इसको डायरेक्टली ऐसे कंपेयर करेंगे. Li plus aqueous has a lower mobility than Na plus aqueous, has a lower mobility than K plus aqueous, has a lower mobility than rubidium plus aqueous, and so on. ठीक है, और आयोनिक मोबिलिटी कम होने से इलेक्ट्रिकल कंडक्टिविटी भी कम हो जाती है. Comparing electrical conductivities or molar electrical conductivities. Electrical conductivities per mole. These ions conduct electricity in solution, and conduction will depend on their ease of movement. जो ion ज़्यादा fast move करेगा, the ion that can move faster will have a greater electrical conductivity. Comparing electrical conductivity in solutions. This will depend on mobility. You can say that electrical conductivity is proportional to ionic mobility, and this is done is inversely proportional to hydration energy. So ionic mobility will have the same order as the electrical conductivity will have the same order as the ionic mobility. The example आ जाएगा Li plus aqueous will be less conducting than Na plus aqueous, will be less conducting than K plus aqueous, will be less conducting than Rb plus aqueous, will be less conducting than Cs plus aqueous. ठीक है, आ रहा है समझ में ये? That's it. We have completed the periodic table. ठीक है, नेक्स्ट तुम लोग बुकलेट कंप्लीट करो पीरियोडिक टेबल का. नेक्स्ट लेक्चर में विल डिस्कस द डाउट्स. ठीक है, ट्यूसडे के लेक्चर में विल कंप्लीट द डाउट डिस्कशन ऑफ पीरियोडिक टेबल. ज्यादा क्वेश्चंस नहीं है इसमें और जल्दी सॉल्व होने वाला है. पूरा थॉरली रिवाइज करो नोट्स एंड देन अटेम्प्ट द क्वेश्चंस फ्रॉम द बुकलेट. पीरियोडिक टेबल का असाइनमेंट मैंने नहीं सेंड किया अभी तक, तो मैं देखता हूँ मेरे पास है तो मैं तुरंत सेंड कर दूंगा. मैं सेंड कर रहा हूँ, अभी ग्रुप में मिल जाएगा तुम लोगों. I've sent the assignment of periodic table. ठीक है, you may solve that also. चलो ठीक है, थैंक यू एवरीवन, टेक केयर, हैव अ गुड डे.